Somewhere out there, right now, it is raining. Not water, glass. And it's not falling down. It's flying sideways at speeds that would tear a commercial jet apart mid-flight. This isn't science fiction. It's a real planet. We've found it, measured it, and clocked its wind speed with actual instruments. And the more you learn about what's happening on its surface, the stranger the whole thing gets. So where is this place? How do we know any of this if nobody's ever been there? And why does a planet 63 light-years away behave like nothing in our entire solar system? The planet is called HD 189733b, and the story of how we figured out what it looks like is almost as wild as the planet itself. You can't point a telescope at something 63 light-years away and just see it clearly. It's far too small, far too dim, drowned out by the light of the star it orbits. So astronomers had to get creative. They used a technique that measures the tiny amount of starlight the planet reflects, and then breaks that reflected light down by color, almost like reading a fingerprint left behind in the glow. What that fingerprint revealed was a planet colored a deep, vivid blue. From a distance, in a photo, it would look almost exactly like Earth. A calm blue marble floating in space, except nothing about it is calm. This isn't a water blue like our oceans. Researchers believe the blue comes from tiny particles high in the atmosphere, likely silicate particles, the same basic material glass is made from, scattering blue light the way our sky scatters blue during the day. It's worth being upfront here. This color reading has been debated in follow-up studies, and not every astronomer agrees on exactly what's producing it. But the leading explanation is a planet whose beautiful blue color is actually made of the same stuff as broken windows. That's strange enough on its own. But the temperature is where things start to feel genuinely hostile. The day side of this planet sits at roughly 1,000 degrees Celsius. Hot enough to melt several types of metal. Hot enough that if you tried to stand on its surface, if it even had one, which it doesn't, being a gas giant, your spacesuit wouldn't just fail, it would essentially begin cooking from the outside in. So we've got a beautiful blue planet, made of glass particles, hot enough to melt metal. Already this sounds like nowhere that should exist. But here's the detail that turns this from extreme into almost impossible to comprehend. The wind speed. Astronomers measured the motion of carbon monoxide gas in the planet's atmosphere, tracking how the wavelength of light shifted as gas moved toward or away from us. The same basic principle as a doctor's radar gun clocking a speeding car, just applied to a cloud of gas 63 light-years away. What they calculated was a wind speed of roughly 2 kilometers per second. To put that into a number that actually means something, that's around 5,400 miles per hour. Some estimates push it even higher, near 8,000 kilometers per hour. For comparison, Neptune, the windiest planet in our own solar system, a place already famous for having the fastest winds we know of nearby, tops out at around 2,100 kilometers per hour. This planet doesn't just beat that. It roughly quadruples it. And if that sounds like an isolated freak of nature, it isn't even the strangest weather system we've found out there. There's another planet called WASP-76b, where the extreme heat is thought to vaporize iron on the scorching day side, and models suggest that iron vapor could condense and fall as metallic rain once it drifts to the cooler night side, essentially raining liquid metal. Astronomers have also proposed conditions on certain hot, carbon-rich exoplanets that could theoretically allow for crystallized carbon, the same element diamonds are made from, to form in their atmospheres, though that one remains far more speculative than confirmed. Which tells you something important before we even go back to the glass planet. This galaxy isn't shy about building worlds that sound like they were invented for a science fiction film. Iron rain, possible diamond skies, and glass moving sideways, faster than sound. So now picture the full scene on HD 189733b specifically. Silicate particles, essentially unformed glass, get whipped up into the upper atmosphere by heat so extreme it would liquefy steel. Then they're caught in wind, moving faster than a rifle bullet. And because the planet is so close to its star that one side is locked permanently facing it, always day on one half, always night on the other, that wind isn't gentle or random. It's a permanent planet-wide hurricane, constantly dragging superheated material from the blazing day side toward the frozen night side. Any particle caught in that flow isn't gently drifting down. It's being fired sideways, horizontally, at a speed that would shred almost anything we've ever built. This is the part worth being precise about, though, because it's the part that tends to get exaggerated. Nobody has directly observed glass raining sideways on this planet. Nobody has a photo of it happening. What we actually have is confirmed extreme wind speed, a confirmed likely presence of silicate material in the atmosphere, and an atmospheric model that predicts those two things combining into exactly that kind of horizontal glass particle storm. It's an extremely well-supported scientific inference, not a fact we've watched happen with our own eyes, which, honestly, might be the most interesting part of this whole story. We've built tools sensitive enough to reconstruct a weather event on a planet we'll never visit, purely from the way starlight bends and shifts across trillions of miles of empty space. It's worth pausing on what "never visit" actually means here, because it's not a matter of distance alone. Even if we somehow built a spacecraft that could survive the multi-decade journey across 63 light-years, it wouldn't survive what's waiting on arrival. There's no solid surface to land on. This is a gas giant, meaning the ground is really just atmosphere that keeps getting denser and hotter the deeper you go, until eventually the pressure alone would crush any spacecraft we've ever built, long before the heat or the wind ever got the chance to. This isn't a place you land on. It's a place you'd simply stop existing inside of. So why does a planet get built like this in the first place? The answer comes down to where it sits. HD 189733b belongs to a category astronomers call hot Jupiters, massive gas giants that, for reasons still being studied, ended up orbiting extremely close to their host star instead of drifting out to a cooler, calmer distance the way Jupiter did in our own solar system. Being that close means being tidally locked, means facing extreme one-sided heating, means violent atmospheric circulation trying desperately to even out a temperature difference that can never actually be evened out. In other words, this planet isn't an isolated freak accident. It's what happens, physically, anytime a Jupiter-sized world ends up parked too close to its sun. Missions like Kepler and TESS have spent years scanning the sky specifically looking for planets like this, and hot Jupiters keep turning up again and again, not as rare oddities, but as one of the most common types of large planet we've found anywhere in the galaxy. We've now cataloged several hundred of them, and that number keeps climbing every year, which raises an uncomfortable, fascinating question. How many of them have their own version of this exact storm happening right now, on a scale we haven't even measured yet? Here's where it gets a little unsettling to think about. Every one of these worlds is completely indifferent to being witnessed. This glass storm has almost certainly been running, non-stop, for millions of years. No eye has ever seen it. No footage exists. It happens purely because physics demands it. Heat has to move somewhere, wind has to carry it, and if there happens to be glass in the way, then apparently it rains. And that's really the quiet punchline underneath all of this. We tend to think of a place needing an audience to matter. A storm isn't really a storm unless someone's there to get rained on. But HD 189733b has been running the most violent weather system we know of in the galaxy, in complete silence, for longer than humans have existed, without a single witness until a handful of scientists on a small blue-green planet pointed an instrument at the sky and decoded it from pure light. Which means somewhere above you right now, completely invisible, there are almost certainly other worlds doing something just as extreme. Storms, colors, physics we haven't even guessed at yet. And the only reason we know about this one is that we happen to be looking in exactly the right direction, at exactly the right moment, with exactly the right tool. The universe isn't performing for anyone. We just got lucky enough to catch one scene of it.